Hi, the goal for this lab, experiment 7, is to determine the activation energy of crystal violet plus OH minus AQ. And it makes this complex, and technically this should be a CV. Crystal violet is purple, and when it reacts with OH, the reaction, the complex is colorless. So the goal is to determine the activation energy of this reaction. So we want EA. And so what we're going to do is we're going to use the Arrhenius equation to determine the activation energy. And so the Arrhenius equation is natural log of K equals minus EA over R times 1 over T plus the natural log of A. And this has a very similar equation to the vapor pressure one that we use, the Clausius-Clapeyron that we used in a previous lab. So if we wanted to do this, really what we need to do is we need to make a graph of 1 over T versus the natural log of K, where K is the rate constant. So if we know the rate constant, and we do this at, let's say, 4 different temperatures, and then we do a linear fit, the slope is going to equal minus EA over R. So really what we want to do here is we want to get we need the rate constant K. The rate constant K. So if we know the rate constant, and we can easily do a measure in lab. We just need the rate constant K. So in order to do this, we need to figure out the order of the reaction. So the rate law is equal to K times the crystal violet to the M and the OH minus to the N. But because the concentration of OH minus is so much greater than the crystal violet, we basically say that this is constant. And so we put this in the rate constant K. So rate will equal K times CV plus M, where K prime is K OH minus to the N. And we're not going to worry about the OH in this lab. So really what our focus for this is just going to be here. So what is M? And so what we're going to do is we're going to just basically we're going to take data, and we're going to take data of time versus the absorbance of the crystal violet plus. And what will happen over time is that it will change over time. And so what we're going to do then is we're going to take absorbance of the crystal violet over time, and then we're going to make 3 graphs. Absorbance, the natural log of the absorbance versus time, and 1 over the absorbance. And if one of these is linear, that will be the order of the reaction. So for example, let's just say for this lab that the absorbance versus time was a second order. So this was a straight line. And this one, so if that was a straight line, then this would look like this, and then this would look like that. So this is a straight line. So if this one is a straight line and the other one's, so how do you know if it's a straight line? You look at r squared, and r squared when you do the linear fit, and you'll see that this one is closest to 1. And the one that's closest to 1 is the order. So this would be, if this was it would be rate equals k prime times CV plus to the second. And so the great thing is that once you know the order, so when you change the temperature, it's always going to be, in this case, second order. And so this straight line, the slope equals k, equals the rate constant k. So basically what you can do then for all of this is what you're going to do is you're going to take 4 different temperatures. You're going to start at 25 degrees. You're going to go to 20 degrees C. You're going to go to 15 and 10. And so what you're going to do for all those 3 temperatures, you're going to start here, and then after that, all you have to do is you make the graph the same graph. So in this example, it would be the second order graph for each one, and then you find k. So then what you have then is that then you have 4 temperatures, 4 temps, and 4 k's. And then you just use the natural log of k equals minus EA over R versus 1 over T plus the natural, plus, C plus the natural log of A. And so in this case, you just make the graph that I talked about earlier, 1 over T, and this is going to be natural log of K, and then the slope is equal to minus EA over R. So really what you're doing in this lab, the first part of this lab, and we'll use red. This is the first part of the lab. You're going to determine the order of the crystal violet. Find M. Okay, you're going to find this. And once you know that, then you can just make the same plot over and over again. In this case, it was that 1 over the absorbance in time. And you can get, at 4 different temperatures, the K. So the next thing is to do this at 4 different temperatures to find K. And then last but not least, you're going to do this to find the activation energy. So that's the gist of the lab. I hope this helps. Talk to you soon.